this is a digital caliper, and it's a device for measuring widths very accurately. And I got a little fellow that I work with who is preparing for entrance exams to a public school in January, and he's very clever, but he's distractible. I think I've mentioned him to you before. Anyway, I wanted to give him a feel for numbers. This is something I've noticed is absent in lots of kids, and I don't know why they don't acquire that feel for numbers in school, but they typically don't. And it means, especially in combination with loss of times table skills and manual number manipulation techniques, it lays them really vulnerable to getting an answer on a calculator that might be wildly wrong because they made a keystroke error and not being able to spot it. So, you know, they might calculate the width of a leaf as 10 kilometers and not see a problem. So I always teach a feel for numbers and estimation techniques. So how wide is that Tipp-Ex bottle, for example? How far is it from this place to this place? And that helps with all sorts of things. And when we're calculating, when we're about to calculate an answer, I say, well, before we get started, let's just get a rough feel. You know, how far is that? How long is that? How big is that? Look at these two numbers. What approximately is, how many times is that number going to that number if we squeeze them to make them easy numbers? That sort of thing. So we did some work on that with distances, just to give it a practical bent, and we can get a bit zany there. So how wide do you think that Tipp-Ex bottle is? Turns out it was 27 millimeters, and let's pretend it's, so about how many of those would you need to put side by side to get to a meter? And before that we did how long is a meter, and then we measured it, and if we laid you on the table, would your head be above the meter or below the meter? So that sort of thing. So, you know, with a 27 millimeter Tipp-Ex bottle, we got to the point where he realized you could get about four in a 100 millimeters, which is 10 centimeters, and so about 40 in a meter. It took him a while to work out that, you know, 4 times 10 is 40. So we're doing sums in there, but we're doing it with a practical bias. We need to find out how many Tipp-Ex bottles you can fit in a meter, and then how many in a kilometer, just to go for the wacky factor. We spent, I suppose, 20 minutes doing that kind of thing. I could have just started straight in on the whiteboard with how many of these go in that, but it's dry, it's purely theoretical, it's all about numbers, nothing about the world. As soon as you add a practical element to the content, you can make it more interesting immediately whilst covering exactly the same material, and you make maths relevant to the world in a world where you need to find out how many things will fit in another thing. So it makes maths useful. It's what maths is really used for. Anyway, fairly successful, I think, and might be something you can use. I don't know. If you've got ideas about how you do these things, by the way, I'm very interested to hear what you've got, so add a comment.